Hello everybody, today is the first day of Crash Course Physics. If you are watching this, it either means that you're studious or it is office hours and you have a physics test next class. This video is an overview of uniform and non-uniform motion. Let's first look at uniform motion in general. So, uniform motion is movement at a constant speed over a certain amount of time. Our example following is of two Knicks that are running at different speeds. One is running at a constant speed left at 2 meters per second, starting 4 meters to the right of the origin. 2 seconds later, another Knick starts running right at a constant speed of 4 meters per second, starting 8 meters to the left of the origin. When will they collide? Please pause the video until you have answered this question.
Left Knick starts at 8 meters per second to the left and moves at a constant speed of 4 meters per second to the right. Right Knick starts at 4 meters to the right and moves at a constant speed of 2 meters per second to the left. Here, time equals x and distance traveled equals y. Using the equation y equals mx plus b, we can plug in the variables and get y equals 4 meters per second times x minus 8 meters for left Knick, and we can get y equals negative 2 meters per second times x plus 4 meters for right Knick. Using these equations, we can write negative 2 meters per second times x plus 4 meters equals 4 meters per second times x minus 8 meters, which simplifies to 12 meters equals 6 meters per second times x, and then to 2 seconds equals x. So the time at which they collide is at t equals 2 seconds.
This is the distance versus time graph. Right Knick is represented by the purple line, and left Knick is represented by the blue line. To find out the time at which they collide, we need to look for the point on the graph where the lines come together, which is at t equals to 2 seconds. This is the velocity versus time graph. Since both are moving uniformly, the lines are represented horizontally with their velocity constant. Since left Knick is traveling to the right, he is represented on the positive side here with a velocity of 4 meters per second. Since right Knick is traveling to the left, he is represented on the negative side here with a velocity of 2 meters per second. To represent the point at which they collide, both lines stop at t equals to 2 seconds.
This is the acceleration versus time graph. Since both Knicks are moving uniformly toward each other, meaning they are moving in a constant speed, there is no acceleration. This is what an acceleration versus time graphs look like all the time for problems with uniform motion.
So the answer to the question is very clear by looking at this graph. If you use a specific math model for both equations, you find these two equations. For the Knick traveling at 2 meters per second, the equation would be meters is equal to negative 2 meters per second times seconds plus 4 meters. For the Knick traveling at 4 meters per second, the equation will be meters is equal to 4 meters per second times seconds minus 8 meters. After you graph these lines, find the point where they intersect. You will find that they intersect right here at 0 meters, to the left of the origin. The origin in this case is where the two people intersect. You can find this algebraically. If you have any questions, please rewind the video. Okay, now, an example of non-uniform motion is free fall. Because objects accelerate when falling, a dropped object will steadily increase as its speed. Let's look at Knick's. At first it moves relatively slowly, but as you get further in the video, the accelerates more and more. Scientists have calculated that the rate of acceleration is 9.8 meters per second meters per second squared. This means for every second that passes, the speed of an object increases by 9.8 meters per second.
This is the velocity versus time graph. Since both are moving uniformly, the lines are represented horizontally
I can't look at them.